Welcome to part 3 of our tutorial series about particle trails in Houdini. And in this part, I want to show you how to use the HDA that we created in the last 2 parts. And I want to give you a bit of a practical example how to use this in production. So you can again download the whole project file and also the HDA over on Patreon. So if you want to get this file, then please check out Patreon and you can choose the project file tier if you only want to get the project file. If you want to watch all my exclusive tutorials, my premium courses, and get the project files for these tutorials as well, then you can choose the full access tier. And thank you very much for your support. This makes it possible that I create tutorials, that I keep my channel rolling. Okay, now let's get started and let's take a look. Last time we left off here, basically. You see that we created this GRM particle trails HDA. And yeah, I showed you some other tricks here. And now I set up a simple scene with a camera here and some lines. So there are only 2 curves for now here. And if we go out of the camera and go to the perspective mode, you see what they are doing. I just created some simple lines. And yeah, I wanted to have a little bit of an offset in Z space. And I also wanted to have a little bit of an offset from left to right so that we have nice movements. And I think you're familiar with the curve tool. I only created these as polygons, as you see here. So just very simple with a few points, and then I just turned them into NURBS. And that's pretty much it. I will show you one little trick that, yeah, may be worth mentioning. I use a setup with 2 views here. So I split my viewport and actually do these 2 views side by side. Then I use one of them as a top perspective and the other one I will set to camera, because this way you really know what you are doing. So now I can come in here and choose the tool. And you see now if I change, for example, this point here, you see whenever I'm moving into the scene or when I'm moving too far out, I can position it really good like this. And that's the way how I really like to set these up, because then I have full control. I know where my points are on the Z axis and I know where they are exactly on the view of my camera. So this is how I created these curves here. And now I want to use my trails HDA with these curves. So how can we do that? First of all, we need, of course, a particle simulation, because that is what is required by our HDA. So let's create a simple particle simulation here. And to do that, again, I need an emitter. And as an emitter, I want to use a circle again. So let's create a circle. And in this case, I will use a primitive here. And I'll go out of the top view here, just to the perspective view. And let's take a look. You see, it is very big. So let's turn it down. And I think that, let's see, I will start with 0.3 for now. And now I want to make sure to line this circle up with my curve. So if I take this curve first of all, so I'm starting with this curve, let's see where point number 1 is. And right now, if I click on these points, you see there are not really many points on this. So I should probably resample it. And that's what I want to do. So let's add in a resample node and just add a few more points in there. And I change it to subdivision curves. That's okay. Now, I want my circle to be aligned with point number 0, so with the beginning of my line. And to do that, I will use a copy to points node. So let's add this in. And now we can copy the circle directly to my curve, my line. As you see, by default, the copy to points is, of course, copying our circle to all of the points. But I can specify a point number here in the target points. And if I put in 0 here, then it copies it only to point number 0, right to the beginning of my curve. Let me show you one more thing. In case if your, let's turn off these points here. In case if your line is facing the wrong direction, that is also relevant with the direction the particles will travel. You can revert it pretty easily. So you go only to the curves node, select it, and then you can select or choose the tool here, this curve tool. And then you can select all points and just click this reverse button here. And by doing that, if we take a look now, you see that our emitter jumped to this point. Now this is reversed. This is also taken into account by the resample node. So let's undo that and let's make sure that we are back to where we were before. Just some undos. Yeah, here we go. Now, another problem that we see here is that our circle, the emitter, is not lined up with the direction of our curve. and there's a simple solution for that as well. Orient along curve, it's called. And if you put this in here right after the resample, you see that now our circle, the emitter, jumps into place. So you see without this and with it, it now points directly into the direction of this curve. So that's pretty handy. Okay, so far so good. So now my emitter is in place. And why am I doing all of this? Because now if I want to come in here and make changes to my curve, then the emitter will follow along. So that's the simple reason, because, you know, during this project I was talking about, I had, of course, to change the paths quite a bit, and it's very useful if your emitter is just following along the curve automatically. And now we actually can create our particle simulation. So let's put down a pop network. And let's wire it up the following. So I want my emitter to be this copy to points node. So let's put it in here. And on the other side, on the second input, I want to put in my curve. And now let's dive into my simulation here. If we run the simulation now, we should get a few particles on our disk, on our circle, and we do, as you see here. But of course, they do not move because they have no velocity. Now I want to move the particles along my curve, and therefore I will use a curve pop force. So it is called pop curve force. Yeah, that's the one. And just drag it in here. And now we have to specify a curve. And instead of a SOP, I will just put in the second context geometry. That is, of course, our input here. So now if you take a look at that, you see this area here, and that is defined by the influence radius. So all of the forces that you see here, we will go through this in a moment, are actually living inside this area that these guide lines are here representing. And in the middle, we have our curve. So this red line in the middle is our curve, actually. Now, if I press play by default, then these particles will start to follow along the curve, and you see they will create a very strange shape, like a bottle nearly. And of course, I don't want this. I want these to be the source particles for my trails. So first of all, I do not need that many. Let's go to the birth tab and let's set this down to a small value like 25. And I also don't want the particle trails to fly so far out from my initial curve. So I will just turn down this influence radius to a very small amount, or to a smaller amount, I should say. The only thing that is important here is that your radius of the emitter should be smaller than your influence radius, so that there is a little bit of space around it. And now this works as following. You see that these particles start to flow along my line, and by default, with the default settings, this already works quite nice. Now you have the follow scale. If I crank this up quite a bit, this determines how fast these flow along my line. But you see that there is one problem. If you take a look down here, and I hope you can see this in the screen recording, maybe I have to go and make my particles a bit bigger. So let's take a look where I can do that. Right here. So if I set it to 5 for a moment, yeah, this makes it a bit simpler to see. I hope this is better. So you see now they're shooting out here just straight. And this is just because the force is now, or the velocity is so high that the follow scale, the suction scale, are not really able to control them. So if I have a very, very high force, like this 10, then I need also a very high suction force, so like 10, for example. And now you will see what's happening now. Now they will be able to follow along my curve again, because the suction force is sucking them towards the original line. But this is anyway way too fast, so I don't want this. I just wanted to show you this as an example. So let's put in another value here, and let's go with some decent values here. Now you see they're traveling around our spline or our curve, and you see again that they are leaving. So you can balance this out between the follow scale, the suction scale, and the orbit scale, but you can also just change this air resistance here. The air resistance more or less is like a scalar value here. So the higher you put in of an air resistance, the more they will follow along these forces here. So if you see now I put it to 5, and now they are following my curve way more accurate, and they're also moving faster through it. So I'm not quite sure whether it is really a multiplier. Maybe it's not really a multiplier, but it is very useful if you want to control the behavior of the particles a little bit better. And let's go to our camera 1 and let's take a look how this movement looks now. So now they're coming in, they're swirling nicely around my curve actually, so I really like that. And this is defined by this orbit scale. So if I turn this to 0, you will see the outcome will be quite different. Now they will not orbit around our curve, but they will be sucked to it. And that's why they are forming, or they're moving in this line here. So the suction scale makes them come to the middle here. And this looks a little bit boring. So that's not that interesting. So I definitely want to have some orbit scale in there, but maybe not quite that much. So maybe I will set it to 0.75 for now. And let's take a look what this does. Then we should not get that much of a spiral movement. And you see the suction force is a little bit too high now because they are being sucked into the middle a little bit too much. So I also turn this down to, let's say, 0.75, and let's see what this does. Maybe this is already something that we can use. This looks quite nice now. They're now maybe a little bit too slow for my taste. So I will just increase the follow scale a little bit, slightly. Let's take a look. Yeah, that looks a bit better. And then you also have this fall off forces here. And yeah, you see we have a fall off force for the follow, or a fall off for the follow force, I should say. Then the fall off for the suction force for the orbit force. And inherited velocity, yeah, is only important if you have already some velocity in your scene, which we do not have. So we can just ignore that for now. You see the follow force fall off means that in the middle of our area here, so directly on our curve, the force will be 1, and outside of this area, it will be 0. So it will be mapped throughout the radius here. But I don't want that. So I want to have a value still on the side here. So I will set this to 0.5. And now these should move a little bit faster and they will not get that slow, as you see now. Now I have a problem that some of them are already leaving again. So I can maybe turn my follow scale here, the force down a bit. Let's take a look. Yeah, this doesn't look too bad. That's quite nice. And actually I will increase the orbit scale again because now they are not orbiting enough for my taste. Yeah, that should be fine. So you can play with these values on your own. You don't want to waste too much time now. But yeah, be aware that there are these fall off things that can really be helpful when art directing these movements. But now let's do one more thing and let's limit our emission to a certain time. And I think that I will just limit it to the first 3 seconds. So I will put in $SF for simulation frame. And this should be smaller than 75 frames because I'm working with 25 frames per minute per second. And this, of course, means that I'm limiting it to 3 seconds. Then it will be turned off, the emission. And then they fly through. Let's take a look at that from here. They come in, do a few swirls, and then they move out. That's perfect. Okay. Now it's time to bring in our HDA that we created in the last 2 episodes. So let's bring in the GIM particle trails. And you see, I have it now here in with my usual tab menu. And I just can bring it in. And by default, this should already work. Now you see we have particle trails. And they have everything that you remember before. So I have this scalar value here. I have this minimum and maximum length settings. So I can change this here, as you can see. So you can art direct your particle trails here really easily. So one more time, let me mention, if you want to get the project file and this HDA, then please check out Patreon. A link is in the video description. Okay, so far so good. So you see, it's really a very simple setup now. So we have these particle trails here. And if we want to apply all of this now to our second curve, the only thing we have to do is to copy all of that. So let's just simply copy this over. And we can now just put in our second curve and activate this. And now you see that we get particle trails right here. And actually, we do not get particle trails because I didn't copy the HDA. So let's do that here. And now we get particle trails. The only thing that we have to check now is that we change the settings that they match this curve here. And actually, I'm not sure why this curve is now. Oh yeah, they're just shooting out. So I think that the suction force is not high enough. So let's go in here and change some settings. And I want these to be maybe a tiny bit faster. So let's just set the suction force also a bit higher, and maybe this also a bit higher. And let's see how this looks now. Let's activate the trails that we see them. And let's see how this looks. And now you see the suction force is too high, so I have to turn this down. Let's take a look. I don't want them to move too close to my line. Now it's not high enough, so let's do this step by step. And that's something that you have to do from time to time, that you just start figuring out these values slowly. Now you see they are not leaving our force anymore, but I also think that they are not orbiting around enough. So let's just increase this orbit scale a bit again. Let's take a look at that. Now they're orbiting a bit nicer. Yeah, that's actually cool, but I want to even increase this. I want to have more orbits here. Yeah, this looks a little bit better. Okay, let's say this is fine. Now we can take a look at the trails, how this is looking. And I think that this looks pretty nice. Okay, so this was the workflow that I actually created for this client project. And then we also wanted the main line to be visible. So I wanted to have one main particle line or stroke that is guiding more or less the other ones, and that the other ones can swirl around. So I wanted to create also an object that is traveling along my main curve. And to do that, there are several ways. What you could do, for example, is you could use a carve node. So you can, for example, choose a carve node. And if we activate this, you can then just animate these lines here. So you can just cut it off and animate this through. And this way you can create a line that is traveling along our main curve. But I chose to do another thing, because here I have to animate two values, and I'm lazy, so I only wanted to animate one value. And I also wanted to have a geometry for my main line. I will show you this in the next part, how to render these things. It's really simple, but in the case of the main line, I wanted to have some geometry, just because it's easier to do, actually. So let's do that. Let's create an object that we can then align to our path. So let's create a line for this. And this also has a reason why I use a line here and not only a tube. So stick with me, I will explain it in a moment. And I want to make sure that the direction of this is one on set, I should say, so that it is laying flat on in our scene. Now I want to sweep this. So I want to create some geometry around this line. And before I do that, let me actually resample it. This makes more sense because right now we have not enough points here. I want to resample it. So let's do that here, like so. Let's take a look how many points we have. Yeah, that should be fine. I'll maybe turn it down to a bit more so that we have smooth curves later on. And now we can just sweep it and use a round tube for that. And it will be very thin, so we do not need that many columns here. I think that this should be fine. If you take a look, Shift W on the wireframe. Yeah, for now, I will leave it at this. Now I want this line to follow along my curve. And there is this cool node that's called Path Deform. And this requires two inputs. So the geometry to deform, that's my, oops, not all of them, only the last one. That's my sweep here. And then we need the curve, of course, and this will be this one here. And if I activate this now, you will see if it works, it should now align it. So let me zoom out here a little bit. And let's take a look where it is. You see it is right here. And now I can only animate one value, and this is this curve offset here, this position. And that's very handy actually, because now I can retime, or now I can time my main line together with my small lines here. So you can template this, and now we can animate these together. The only problem that you see now is that this is not long enough. So let's increase the size of our line. So we do this right here. And let's see how much we need, maybe 10. And let's zoom out here a little bit. Let's see how long 10 is. And if I go to my Path Deform and just set this back a little bit. Yeah, this is actually good. So I will leave it at 10. And now, and this is also why this path deform is useful, because I can use the sweep scale now to apply a scale over this length here. It's very similar to what we did before when we manipulated the p-scale with the vector angle, with the point angle. But now I will just do it like this and just use this curve here. It's a little bit simpler, faster. So let's just do it like that. Set up a simple curve, choose all of these here, and make them interpolation. Let's do it here, then you can see it. Interpolation, let's say monotone cubic for now. And if we take a look at that now, then yeah, it looks like this. And it is of course too thick overall. So let's change the radius to 0.01, and then it should be nice and thin. Okay, now let's merge these two together and let's just animate this. So that's very important to animate this. Let's select it and let's take a look so that we time this. And I also want to do that in the camera view because then I can see what it's doing. I know that I want to start at position 0. So if I start at position 0, yeah, you see it's not totally gone because it is very long, but it's no problem because I can actually drag this into the negative values. And right around here, let's say wherever I need to start. Oh, sorry, like so. So at around, what do we have? Minus 0.51, you see that it is outside of my screen. So I will start here, add a keyframe, alt-click. Now let's run the simulation because I want to see when my lines come in and I want to create a nice timing. So now they are leaving here. So we can scroll through this now. At this point, I want my main line to be out of the screen here. So let's drag it over. Let's take a look until there. Then I create another keyframe. And then let's take a look when it should be gone totally. And I think right here, it could be off screen already. Let's take a look like so. And another keyframe. And I could actually set this to 1. And we have nicer values to manipulate. Now let's take a look at this all together. It's coming in here, speeding through, and going off. And you see right here, it's still a little bit visible. So I want to make sure that I update this keyframe to 1. And again, keyframe this. If you want to manipulate it, shift click, of course, then you can take a look at your keyframes. And I think I can delete the middle one here and can just manipulate this like so. I don't want to ease so much. I just want this to be a little bit more linear. And I think that this should now work. Comes in, the other lines follow along. Maybe it is a little bit too fast now in the beginning. So what I could do is just move this over a bit. Like so. Let's take a look. Oh, sorry, I'm out of my recording area here. So you could not see what I'm doing here. I just manipulated this here. So let's take a look at that again. Yeah, now I just pushed it a bit too far, so I will bring this in again a little bit. And this way I can just time these two animations. Like so. Yep, that looks nice. Okay. Good, the animation is in place. And of course, now I can do the same thing for the other particle, but I won't do that now. You can take a look at the final project that you can download on Patreon. There, everything is set up. Or you can just do it alone, because now you know how to do it. And there's one more thing. The client at one time came and said, it would be nice if there are some particles in the scene. And because this is Houdini, and it is so cool, we can do this in a very, very simple way. And this is also one reason why I wanted to use some geometry here, because I can use it to create some particles, and it's pretty simple. So let's create another pop network here to add some particles to this scene. And we can go directly from our Path Deform here and can take this as an emission. So if we activate these particles now, you see right away we have some particles in here. Now they do not move, of course, but they are already spawning on the surface of our object here. So to move them, I will come in here, and first of all, under the Attributes tab, I can set an initial velocity here. And I want to use an inherited velocity. But the problem is, as you see, it is not working. It should take over the velocity of our geometry. But actually, because this is a path deform, there is no velocity attribute. As you see here, we only have position for now. So we have to calculate this velocity, and therefore we can use, again, the trail node here. So let's put this in here, and let's set this to compute velocity. And by doing that and re-simulating, you will see the behavior now is very different of our particles. Now they are shooting out in the direction of our velocities here. This is not exactly what I want, but it's a good starting point. So let's go to the POP network, and we will turn down this value a little bit. So set it to 0.5, then it will inherit half of the velocity, and this looks pretty good. Now there are only two things I want to add, actually three, actually four. So I want to add in a pop drag, first of all, to make them a bit slower during this simulation. And let's see how much air resistance I really need here. If I put in 1, they are already way slower, as you can see here. And let me turn down the point size now again, because now they are a bit too big. I would say, yeah, that's better. So something like that. That looks quite nice. So I will leave the air resistance at 1. Now let's put in a pop force to add some turbulent displacement here. We could also do that with the pop warp and add some noises, but I think this is okay. So let's take a look at that. I will just add a value of 1 here. As you can see, looks pretty good. The swirl size is maybe a bit too big, so I'll just turn this down a tiny bit, maybe turn down the roughness a tiny bit. Let's see how this looks now. Yeah, that's a bit better. And I just want to turn down the amplitude also a bit, so maybe 0.75. Let's take a look. And that's fine. And as a final step, I want to, again, control the size of these particles. And I want to control the size of these particles over life. So what we can do here is, again, use a pop warp. And it's exactly the same setup that I used before with these trails in the first part, if you watched it. If not, I would recommend that you do so, because then you can learn way more. And now I just want to bring in the age and a p-scale value that we do not have right now. So let's actually bind in a p-scale value, and by choosing bind, or by putting in a bind parameter, I can create an attribute actually, because I think that these, or actually they do have p-scale, do they? Let me take a look. They have, no, there's no p-scale on them. Yeah, doesn't matter. We're creating p-scale right now. So here we have p-scale. And then again, as I did before, I want to fit the range of my age. I want to put this through a ramp parameter. This should be a spline ramp, like so. And then I want to multiply this. So let's say multiply my p-scale value with my ramp value here. And then we can bind export this. So we can export it again to p-scale, like so. And now we can go up one level. Actually, there is an option, another option that we could do. I could bring in another multiplier just as a constant value. So if I, or not a constant, a parameter actually, because this way I can just, no, this was the wrong thing. I just need a parameter, standard value or standard node, this one here. Yeah, let's make a little bit more room here. Because if I multiply this in here as well, then I have an overall multiplier, and I can name this now my overall scale. And I think that this is fine. Now, the only thing that I have to do is to put in my min and max values here, so what I want to map from the age. And to do that, I have to specify the lifespan of my particles. And I think I don't want them to live that long. So I think 3 seconds should be the maximum. So let's go to my source here, and let's go to birth, and let's set the life expectancy to maybe 1 or 2.5, and then a variation of, let's say, 1. And let's see what this does now. So they will die off between 1.5 seconds and 3.5 seconds, and this is a little bit too much. So let's do it 2. Then I think this should work. Yeah, that looks a little bit better. Now they are gone. And what I can do, I can just deactivate the emitter here at around maybe, yeah, let's say 175 frames. So again, as I did it before, $SF should be smaller than 175. Good, so this is a very fast particle setup. As you can see here, we have just some particles. And there's one more thing I want to do. So actually I'm adding more and more stuff here, but this is very similar, or very, very simple. We just want to use a pop color here. And then we can set up whatever we want. We could use an attribute like velocity, you could use whatever. But I want to use a ramp, and actually not a ramp, I want to make it random. That's it, and just by the ID. Then I have random color values, and I can later on use this in the shader. I will show you this in the next part, how we can render this using Redshift. So this is what we get now. And I think that this is pretty nice. So if we play everything together, merge in these particles as well here, then this should be fine. Yeah, that's pretty good. And it's very similar to the setup that I created for this client project. Now, there's one thing that I want to do, or the last step in this tutorial, in this part of the tutorial, is that I want to prepare everything here for rendering. What I usually like to do is that I separate these things. So you see we have our small lines here, we have this main line here, and we have these particles. So I will put in nulls here and just export them separately. So let's do it like this and rename these. So here I will put in lines, or let's make it out small lines. That makes more sense. Here we make it out main line, and here out particles. And I like to colorize these green, but everybody has his own preferences here. So let's go up one level. And now I just want to create a geometry node for each of these outputs. So I will create a geometry node for the particles. I want to create a geometry node for, and you can also put in something like particles render, for example. Then you know these are rendering something. Then the small trails render, okay. And then we just put in the main trail. And then again, that this is a render. Now we can make these green, that we know these are visible. We can turn this one off, and then we go in here and use object merges and bring in the geometry that we want to link in here. Right here, this will be the out particles. Then in this one here, object merge. This will be the out small lines. And then in this one here, we want to add in an object merge. And we want to point this to our main line. Okay, now you see that I have everything here. And yeah, this is actually where we can proceed to the next part, and this will be how we can render this in Redshift. So thank you very much for watching. Once again, if you want to have the project file and the HDA, then please check out Patreon.